Hey guys, welcome back to our channel. In our last video, we've integrated ImagePicker into our app, allowing us to pick images either from gallery or using the device camera. Here's now the code we left off from our last video. And as you can see, this lacks the error handling mechanism, efficient state management for loading processes, and integrates the ImagePicker class directly into the UI. This makes it challenging to test and maintain, and it's not scalable when you need to add more functionalities. So in today's video, we're going to level up our image picking system to the next level. We'll refactor this code to decouple it to our UI, making it modular, testable, and maintainable. And as usual, let's outline the blueprint of our target architecture. This way, we can have a full understanding of what the components that we need, and how each component interacts with each other. So this is our chat room screen that contains the buttons for fetching images. And the first thing we need to do is to create our own implementation of the ImagePicker class. So we'll create an app ImagePicker class here. This class is our custom wrapper around the external ImagePicker class. By encapsulating this, we gain flexibility, especially when writing a unit test. Then we will create an app ImagePicker service here. Think of this as the brain behind our image picking operation. It communicates with our custom app ImagePicker class to fetch images. Once fetched, it interacts with our controllers to manage and reflect these images in our UI. Now for the controllers, we'll have this image editing controller class. This class functions similar to the text editing controller, which acts as a storage box for the picked images. It keeps track of all the picked images and ensures they are ready for display or further processing. And this image picker controller class is a class responsible for managing the asynchronous state of the UI, and it updates the UI based on the current state of the operation. And I initially considered integrating the permission handler. However, to keep things beginner friendly and avoid overcomplicating this video, I've chosen to omit it. But if you're keen on adding it independently, consider creating a permission handler service class and integrate it within the app image picker service class. And if you find the service becoming too bloated, introduce another class here and inject the permission handler service there. Alright, now that we have a full understanding of how we'll structure our image picking system, let's go ahead and get our hands dirty. Let's start with this app image picker class. As a short reminder, here at joberTech, we use RiverPad as our state management solution. But if you have a preferred state management solution of your own, then the architectural insights for this tutorial will still be valuable. Okay, what we're gonna do is to make our image picking system as one of the primary features of our app. So inside our features directory, let's create an image picker folder. Let's also create the application, data, and presentation folders inside. Okay, let's start now creating this app image picker class. Okay, we only created two methods here for picking images, because these are the only methods we need. But feel free to add more functions that you need here, like this pick media, pick multiple media, pick video, and so on. So here in the pick image, what we only did is to convert the result to file, because this is of type X file. The same is true with this pick multi-image. We fetch multiple images, check if it's not empty, and loop through each item to convert to a file, and then add to this list of files, and then return the result. And then we created the provider of the class here. Alright, let's go ahead and create the app ImagePicker service class. Okay, we are fetching the image here, but as you can see, we are not doing anything about the fetch images. We don't want to propagate this to our ImagePicker controller class, because that is for managing the synchronous state. So as explained earlier, let's create the image editing controller class. Since we already have a generic custom list controller class that extends this state notifier of type list t, and it contains all the basic operations that we need, like this add item, add all, replace, remove item, and etc. Let's simply extend this class and give it a default value of empty list. Alright, that's it for this class. Let's go back to our app ImagePicker service class and store the pick images to this class. Alright, that's it. Take note that we added this allow multiple parameter, and check if the allow multiple is true, then we add the item to the controller. If false, then we replace the previous value with the newly fetched value. And here in the pick gallery image, if allow multiple is true, we fetch images using this pick multi-images method and add the result to our image editing controller. If false, then we use this pick image method, passing in the image source.gallery as a source, and then replace the old value with the newly fetched image. Just like that. Now that our app image picker service is done, let's move on to our image picker controller class. Alright, for those who aren't familiar with this, you can check my video about easing state management in Flutter here. Let's go ahead and set up a UI to use this controller. Alright, as you can see, we instantiate the image editing controller here, like how we do with the text editing controller. Let's try to display the image contained in this image editing controller shortly, but for the moment, let's just print its length inside our build method. I think everything is now in place. Let's go ahead and restart our app to see if everything is working as intended. Okay, it's working as intended. As you can see, the value is being printed in the console as expected. But the problem is, the loading indicator that we have added isn't positioned correctly. So let's address that. Let's change this full suffix widget with the loading indicator when our controller is in a loading state. And let's temporarily display the content of this image editing controller here just above the text field. But the problem is, this controller is defined here inside this ImagePicker button, which is a child of this chat text field class. How can we access the value of this controller in its parent widget? The most naive solution is to lift the state up. We need to define this in the parent widget and pass it to this child. But that can be a tedious work, especially if the child is deeply nested within the widget tree. So I suggest wrapping this in a state notifier provider. This way, the value becomes accessible anywhere in our app. Okay, let's try to use this provider and display its content. So this is now the chat text field widget. It comprises a row with a text form field and a send button. For demonstration purposes, let's wrap this in a column and place a row on top. Alright, let's test this out. Okay, everything is working as intended. You can now customize this further on your own, so that the user can still have a chance to remove items or rearrange the order of the images before sending or uploading. That's it, guys. Thank you so much for tuning in. If you found this video helpful, please give it a big thumbs up, share it with your fellow Flutter enthusiasts, and don't forget to hit the subscribe button. See you on the next one.